Number 21, we're going to do another substitution problem. This one happens to be isolated, the y. It comes naturally out of the book that way. Y equals this. So what students need to know is wherever they see a y over here, they can put x plus 7 right there, substitute for y. And just to reinforce what I said before, by putting the information from this line in place of the y in this one, we are effectively putting the lines together, which is where the point of intersection can be found. So, now back to this other point I made, always put parentheses around. You can see now clearly the y has turned into this, and you've got to put those parentheses around it, otherwise some bad things can happen. You'll get the wrong information. If we hadn't put the parentheses here, we might end up saying 3x plus 7, but that's not what we really have, because we've got to distribute the 3 to both, so it's going to be 3x plus 21. Okay, now we combine these like terms, 5x plus 21 equals 31. Take away 21 from both sides, that's 10. 5x is equal to 10, so divide by 5, divide by 5. 1x, x equals 10 divided by 5, which is 2. So there's half of our ordered pair. Now we just need to figure out what y is. So we take this 2 and we can plug it back into either one of these. Let's go ahead and do it here. That looks pretty simple. Y equals 2 plus 7. And this would be, I'm substituting here. I'm not going to have a big heart attack if we don't forget the parentheses, but if you want to be a real strict, disciplinarian about your substitution, that would be wise, I guess. So 2 plus 7 is 9, and there's the other half of our information. So now we know that on the graph at 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, way up there is our point of intersection. And we don't know the way the line looks without thinking about graphing it, which this one would be easy to graph. This one we'd have to move stuff around a little bit. But that's not what we're being asked to find. We're just being asked to find the point of intersection. And so we're basically done as soon as we find this ordered pair. However, on a test or a quiz, you'd want to plug these back in and just check to see. And we can do that. Take the original equation, put the 2 in for x, and the 9 in for y, and see if it turns out to be true. Because if this point is on this line, and we do this, it should spit out something true. True. And in previous videos I went ahead and wrote out, I would actually like to see my students say, yes, 2, 9 is on the line, solution. And over here we have y, I'm thinking right here, y, let me go ahead and write, even though I didn't copy the original down here. So put y in, and x, and there we go, 9 equals 9, so true. So true, I'm just saying shorthand, or solution. This means yes, that point is on the line. Yes, that point is on this line also. If it's on both lines, then it's a point of intersection. And that's how you check to see if what you did is actually true. So as I said before, there's no excuse for students getting these types of problems wrong, because as soon as they find a point, they can plug it back in, and find out if they actually did it right.